This is the Alpine 210 boiler. We recently converted from oil to natural gas. And the good thing is, what you want to do is if you're considering converting, you should contact your gas company. In my case, it was National Grid. And after filling out a tremendous amount of paperwork, spending a month or two on the process, we were able to get this boiler shipped to us actually at about half price. It cost about $2,700. It generally goes retail for about $5,000 and change. So I'd say we got it for about half price. There's a lot of bureaucracy involved, and actually by us it was already getting cold. We had gotten it in I think in November or so, till we finally got it, and got pretty cold in the house. We didn't have any hot water for a while. We had to use this 4-gallon hot water tank in the meantime. And I can tell you, it's no fun showering with only 4 gallons of hot water. But be that as it may, we were able to get this unit. We had it installed. Just give you a quick look at it. It's mounted on, looks like 4 half cinder blocks. And basically we had upgraded from, we had oil when we first moved in and we converted. I really do not recommend oil. For a number of reasons. First of all, it's much more expensive. Natural gas is much, much cheaper. You want to go with natural gas. You'll save a lot of money. You'll break even in just a couple of years. So I would really recommend converting from oil to natural gas. And the other problem you can have with oil is, first of all, you have to deal with the oil companies, with the deliveries. They do deliver, they don't deliver. The other thing I would point out is you really have some environmental concerns with oil. In other words, I know from someone who said that when they had a problem with their oil tank leaking just a little bit, they called up their oil company and they said, look, we're having a problem with the oil tank, it's leaking a little bit. The response of the oil company is, we have to report you now to the town because it's a leak, it's an environmental hazard. Well, the town inspector came down, issued them some violations, some mandatory cleanup, and after hiring a professional company and $10,000 later, they got the problem taken care of. But there's a concern there. There's an environmental concern. Why should you store hundreds or 1,000 to 2,000 gallons of oil? What do you need that for? You have gas, it gets pumped into your house, you don't have to worry, you don't have to think about it, it's cheaper, it's a no-brainer. In fact, when we had to upgrade for this and for the generator, we got a new gas meter. And I'll tell you, first of all, it doesn't cost anything. They'll upgrade you. And basically, when they come, just tell them you're getting a gas boiler, you're having a barbecue, and you're having which uses a lot of gas. You may be getting another oven, and tell them you want the biggest meter as possible, as big as possible. And I'll show you the meter, but I want to show you also they did some nice job cleaning up the pipe work. Coming into the house, I don't know if you can see, it's a small pipe. It's only a 1-inch pipe, 1-inch gas pipe. And it's not a lot, but nobody's changing that. And we have a lot of gas demand because we have the generator, which you can watch my other video, a 20 kilowatt gas generator. And then you have this pipe, we use a lot of gas. And they did put in a big meter, which I'll show you, but they upped it. In other words, even though it comes in at 1 inch, it then goes to 1 1/4 inch, which is good, even though there's that restriction coming in, but it still makes it less of a restriction over here. It's 1 1/4 inch pipe. And then here, if you notice, there's something like an anti-static ring. I think it's made of, I don't know, some kind of plastic insert, and that keeps the static from possibly igniting the gas, they say. So it comes up, goes down, comes up, and I'll show you it going out, but let me just show you the meter. Basically, there are numbers on the meter. If you look over here, this says, let me see, AC 630. The bigger the number, the more cubic feet you'll get in to the house. I think it means it's MAOP, it's 630 CFH, cubic feet an hour. I think that's what it is, 630. We had one, it was like 120 CFH. It was just for cooking. So this is a major increase. I will tell you, if you don't have to upgrade your meter, there's a reason why you should not upgrade your meter. When they came in to do this, the workers told me that an old meter is a plus. They consider it to be a plus. Why? Because if you have a 20-year-old meter, inside this meter they said are bellows. There's some bellows that the air comes in, it measures it, and then it shoots it out. They said that the bellows stretch over time. So you're actually getting some free gas over time. On each shot of the meter, you're getting a little bit extra gas because everything's stretched out. It's less accurate. So that's one reason why you shouldn't upgrade your meter. If you want to know why you shouldn't, that's a reason. In this case, we really didn't have much choice between the generator, the barbecue, the gas heat. We just needed to upgrade. So we did it, and I got the biggest meter you can get, pretty much. They were very nice, the guys. I just told them put in the biggest meter, and they went along with it. It goes out there. The plumbing goes, I don't know if you can see. Let's see, where are we? Here's the pipe. This goes to the generator. I've labeled everything, so if I'm not around, and it's good to label everything. So if you have a problem, like there's the barbecue, oven, where is it? The dryer, and it's important to label everything. There's the boiler. So if you're talking on the phone, if there's actually a problem and there's an emergency, you can, and in your wife's home or someone else's home, you can say, look for something that's labeled generator and shut it off. You know, same thing with the water. You have something that says water main shut off. That's important. If you have a leak, someone should shut it off. But in any event, back to the boiler. The plumbing goes up there, it goes in the ceiling, and it comes down over here. And that's the gas line into the boiler. Now, it's a condensing boiler, which means that it gives off condensation. You see this thing here? Water drips out, it goes there, and that's what's called, I think, a big boy pump or something of that nature. It's a pump. They use it in air conditioners and these types of heating systems. It basically takes the water and it pushes it up. Why does it push it up? Because over here, if you go across, the drainage for the central air conditioning system, we have a drainage for the central air conditioning system. It goes around and it goes into a pump that we have in the ground by the laundry room. So we need to push this condensate up so it can go across and into this pipe that goes around. So looking at the system, it's a very efficient system, and what it does is, if you can look over here, let me show you. There are two pipes that go into the boiler, okay? And which one's which? One of them is a vent pipe. I think that's this one. Let me see. Going to the right is a vent pipe. In other words, this is where the hot air gets expelled. This one is where the cold air gets sucked into the boiler. Now, they're both leading outside. So why does this system pull air in from outside and vent outside? Now, it's important, obviously it vents outside because it's venting out carbon dioxide. Now, it's sucking in air. Why is it pulling air from outside? Well, because it's very efficient. If you have like an old boiler, as your general boiler light, that's just sucking air from inside your house, you're burning warm air from in your house. And this burns a lot of air. It's using up a lot of air. So why should you burn warm air from inside your house? You want to burn cold air from outside. And that's why you save it. You can save a lot of money by not burning the warm air inside. So that really saves you a lot of money and efficiency. And what's amazing is it's keeping so much of the air inside here, so much of the heat that's produced inside, that it's actually able to vent out of PVC. Could you believe that? I mean, I couldn't believe it when I first saw it. You know, instead of venting out through aluminum, it doesn't need that. It's the air coming out is just warm moisture. It's not going to even melt PVC. So it shows you it's keeping in so much heat. And if you look at the energy starts 95. It's pretty close to being the highest efficiency. It says the model. I think it said the model number up here. ALP 210W. So it's very efficient. The other benefits are, it doesn't need a chimney to vent out, and that's a big thing, because by not needing a chimney, we were able to move this boiler from where it used to be in the center of the house, and now we have it in the corner of the house because we can just vent it out the side. You don't need to attach this to a chimney, so it gives you a lot of flexibility as to where you want to install this, and that's really a big benefit. The other thing it has is it has an outdoor sensor. You put the sensor outside with a wire. I think it's this one. There's a couple of wires coming out. I think it's this one, which tells the boiler how warm it is outside. So in other words, if a bedroom or a room calls for heat, and the boiler is going to say, wait a minute, how cold is it outside? Well, if it's 30 degrees outside, the boiler is going to say, oh, they want heat, I'm going to heat up to 180 degrees. So that there'll be enough heat to heat up that room, maybe plus another room. But if the temperature outside is, say, 60 degrees, and it gets a call for heat in one of the rooms, the boiler says, wait a minute, okay, it's really not that cold outside. I'm probably not going to be asked for a lot of heat. So instead of heating up to 180 degrees, I'm only going to heat up to 130 degrees. And what that'll do is, that'll save you a lot of energy. So it doesn't heat up all the way, and then it'll give a little heat to that room, and then it'll shut off. And this is because it's not expecting a heavy load or a heavy request for heat. And that'll save you money over time. And so all of these features really translate into a huge, noticeably huge energy savings. I mean, we're heating up about a 6,000 square foot home. It's costing about $300 a month for most months. We're on Long Island, New York. And on the coldest month, it cost us about $560. So we're really seeing a big energy savings on that end. And but though I will tell you, it is a 210,000 BTU unit. It's probably a little undersized for this home, but it's just the paperwork for getting anything bigger. This is the standard on their forms. This was the largest that they had. It was possible to go larger, but it was just too much bureaucracy. And like I said, it already hit November, and if we didn't get the boiler in, we'd have to move. So we got this boiler, and I will tell you, it is sufficient for what we're doing. Though I think a bigger one would have been a little better. It is sufficient because we have so many zones, and I'll give you a view of the zones. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 zones here, one of which is going to the hot water tank. I try to give you a view of this. It's difficult because in this room everything's so crowded together. And I've covered it with Frost King makes this wrap. It took me days to do this, a little bit each night. It's 10 zones here. Each side, and I'll show you that. And one of these goes to the hot water tank. And then we have in the back another zone for the radiant heating. That goes across here, and if you look at this system, this is the radiant heating. It's the hot water going up and the water returning. And basically, what these units do is it spreads the pressure out. It makes sure that the water going up goes up evenly to each section of the floor. In other words, there are 5 returns. It's really just for the kitchen. There are 5 returns. Or I guess you could say 5 sections of the kitchen floor, 5 separate runs of the tubing, and this is all PEX, so that it's even. It'll go through evenly. You won't have one part of the floor warmer than the other part. It really is excellent. I never had radiant heating before, and I will tell you, that it's just fantastic. It's efficient, it's warm, you save space in the kitchen. You do not need to have a radiator there, and we would need a big radiator. This house actually is 100 years old. There's no insulation unless you count those old those old newspapers stuffed in the walls as being insulation. Some of them were interesting to read. It dealt with the communist threat. It was actually quite interesting. But in any event, let me show you what it's like. Each zone has a pump. These are the standard TACO pumps, TACO, and they pump up, and the return comes down on the other side. And if you need to bleed these, we have valves here. You shut off this valve, and you bleed this one. You just let the water out. You basically let the water come in by turning on the main water intake, and you put a hose here, and you shut off this valve underneath it, and it lets it flow through and bleeds it. But you don't only have to bleed it once, or unless air gets in the system somehow, like if you do work on it. So I've covered all this up, and that's helped a lot. And I've also ran as much as I can in this room. I've covered all with Frost King material. And I tell you, that actually dropped the temperature in the room by 10 degrees and is forcing all the heat up. So even though I would say the boiler is a little undersized for this home, it works fine because we're never actually heating up the home the whole home at any one time. But we're heating up one section. We're heating up at night. We heat up the bedrooms, and we keep the first and the basement and the first floor till in the 50s. In the day, we don't have heat in the bedrooms. We keep it at the 50s, and we just heat up the main levels. And it's all programmed with thermostats, which I'll show you. One thing I did was, and I'll try to show you later, is when I turn on the hot water, is I drilled a hole in this TACO pump. In other words, I wanted to see when the pump is on for the hot water tank, because we had some issues with that, and this now it seems to be taken care of. But this will show me when this pump is on. I put in a 120 volt LED. I drilled a hole in here, attach it to the wire, so whenever this gets power and this is pumping, the light goes on. Sometimes it's difficult to tell which one's on. It would be nice if I had lights in all of them, but I think it was like a $10 bulb, and I don't think it's worth it. So I have it for the hot water to show me whether the hot water's on. You can see all the TACO pumps. We have 10 of them there. Now, the way this works is there's a main pump. This is the boiler, the side of the boiler, and there's a circle. This big pump over here is a main pump, and that's just pumping it amongst this first circle in here. There's like, you can see this and this. It is like just a circle. It goes around, comes around, and that just circulates the water, pulls it out of the boiler, and makes it go in this big circle across here and then here. Then all the pumps take it off that circle and pump up. Whenever there's demand, it pumps it up to that particular zone. It seems to work very well, this system. The only problem we're having is with this zone, the highest level in the house, in the attic level, for some reason, even though the pump's not on, the heat migrates up. And I'm not sure if there's something wrong with, there's supposed to be some thing in there to prevent the heat from going up when the pump's not on. But the heat's going up anyway. In the winter, it's not a problem. We could always use a little bit of heat there. In the summer, it's a problem because whenever it heats up the hot water, it's heating up that zone too. So we just shut off this in the summer after the winter, and it basically keeps that definitely keeps the heat from going up there, and that seems to work. A little jury-rigged, but it works. Now, let's take a look at this. I think we've covered that. Now, looking at the boiler, it'll show you a lot of information that you should look at. And by the way, before I get to it, here's the hot water tank. This has its own LED when it's calling for heat. Right now, it's not on. You can see over here, there's a little light there. It's dark. And the reason it's not on is because I don't allow the hot water tank which is its own zone here, to actually make hot water in times when we're not showering. Basically, I've interfered with that at the with my timer system. I have a timer over here that controls the hot water thermostat. You should watch my other video about what I call the intelligent timer system, and that's interfering with the hot water thermostat. It's shutting it off when we're not using hot water. I also put in a switch over here to control another way of shutting it off. Right now it's in the on position, but it's being shut off by the timer. But if we go on vacation, I can actually shut off the hot water. So if we go away for 2 weeks, I just shut it off so it never makes hot water during those 2 weeks. And that also saves money. And I'll show you how that works. Basically, going back to the boiler, here's the boiler. There's a nice little screen here, which I think looks a little flickery. And I saw it on my friend has a similar system, and I don't think they last that long. But whatever. Now it'll show you the status. Here's the status. You can click on status. The boiler's at 78 degrees. Set point. I think that's the most it'll go up to in this weather is 130 degrees. It says priority. Now it says warm weather because it's warm out. It's the summer. Right now it's June. Now it should be. I'll tell you what. It should say priority hot water. It says warm weather because that overrides it because there's no heat now in this. It knows the temperature outside, and I'll explain what that means in terms of setting the priority. And it says status standby. Supply 78 degrees. It shows you a lot of information about it. I don't know, trends. Let's see what this is. I don't know. Supply temperature. I guess it's good for diagnostic purposes. I don't know. Okay, and let's see what else. Detail. Now you can show you detail, central heat. Set point source, outdoor reset, which is showing you that you have this outdoor thermostat wired in properly, which is good. And you have to set that in the settings. It's very important. If you ever reset this boiler because you're having a problem, it's going to delete all the settings. So you have to make sure it's set appropriately. Now let's see, domestic hot water, set point. The boiler will get 180 degrees to heat up that hot water. That's good. Now to get into the advanced adjust, if you want to adjust it, it says warning. Only qualified technicians should adjust these controls. All right, well, let's just adjust it anyway. Now, to log in, you need the password. And I think the password is the same for all these boilers. It was printed in the menu. It didn't look in the manual. It didn't look special, but let's see, log in. It should be all the same. It's 076. Enter it. Okay, now hit adjust. It says press save to send. I don't know. Some crude menu. Okay, now we're here. System setup. Don't mess with this unless you know what you're doing. And it's not difficult. You just have to read the manual. If you go I programmed this myself because we reset it when we had some issue. You just choose you either Fahrenheit or Celsius. Obviously, we want Fahrenheit here. Adjust the screen. Now, outdoor sensor source is installed because we have the outdoor sensor. Hit this arrow to move to the next one. Frost protection enabled. I guess it prevents it. You know what that probably does is prevent the system from freezing, monitors the temperature, and that protects you. If for some reason it's shut off, or nothing calls for heat, or there's some problem, it'll make sure it doesn't freeze and burst, which is good. Warm weather shutdown. I guess it shuts it down if it's too warm outside. If it's above 70 degrees, it's not going to let the heat go on. I think that's what it is. Okay, X out. Contractor setup? I don't know. That's a little scary. Let's see what else there is. Pump setup. Okay, central heat, optional priority. Run pump for any demand. Now, the priority means that if the hot, let's say that you need heat, thermostats are calling for heat. What priority does is, and then let's say the hot water tank calls for hot water at the same time as the house is calling for heat. You want the system to give priority to the hot water tank. And you want to set it through here. Don't set it through the relay boxes. It never worked right. So what this does is, this priority will not give, even if the house needs heat, it won't give heat to the house. It's not going to let those pumps run, even if the thermostats are calling for heat. It'll instead give all of the energy to the hot water tank. So you'll have hot water for your shower because it assumes that's more important, which it is. So you have to set that in here. The other thing it'll do is, and that's good, this way you'll always have hot water for your showers, but there's a safety built in that if it can't satisfy the hot water demand in 1 hour, then it'll then give heat back to the house. So in other words, if there's some problem, like let's say you have a hot water leak in your sink and it's just running all the time, and this system can't get the hot water warm enough, because it keeps running, it'll say, all right, after an hour I've tried, I give up, I'm giving heat back to the house so your house doesn't freeze. And that's another nice feature. This is really like a computer. The next feature is run pump for any demand. I think it just means it runs the main pump whenever there's any demand at all. Whenever there's any demand on any of the thermostats, it'll run this main pump to circulate around the main loop. I think that's what it means. I don't know what it is, but this is the setting I think the manual told me to. Primary loop piped IWH. That's a standard setting for this type of system. Okay, let's see what else. All right, let's take a look. Contractor setup. You put your name in. I think that's really what it is. Modulation setup, Alpine. Factory password required. They don't want you in this boiler. Oh, I think this you can actually like change the how hot the boiler boils, and you know, a lot of things that they really don't want you involved in, which makes a lot of sense. Manual control, I don't know. It's all in auto. More, I don't know what that is. Central heat. Set point 180, that's how hot it'll allow it to get. THW, that's how hot it'll get for the hot water. Okay, these are the systems, and it's quite sophisticated and really quite impressive. I'm actually very happy with it. Like I said, it seems to be able to heat up the house. The only issue we have is sometimes when there's a big demand for water, you will feel the house temperature drop a little bit because it's working so hard to heat up the hot water. So what I've done is I have with my intelligent timer system, going back to over here, I have it turn on the hot water about an hour before we come home. This way it heats up the hot water. The system is not going to be on, and therefore nothing's going to be requesting heat. It can give all the energy to the hot water anyway. And then after after it's done, the boiler's still hot, then the rest of the system will go on because the thermostats are going to demand it, and you're not wasting any energy because the system's already hot. So by timing the hot water to generally go on right before, an hour before the system, before the house is going to request heat, you're actually more efficiently using the heat in the boiler. Now there's a thermostat there. And another word about the exhaust, if you do want to hook this up to a regular chimney, you might have a little bit of an issue doing that because it puts out a lot of steam. The exhaust, which I can show you, it puts out a lot of humidity, and it'll destroy a regular chimney. You're going to need to put a liner in that chimney, and you're also probably going to need to have something at the bottom because when it goes up, all that condensate's going to start dripping down, and you need something to catch that condensate. So I would recommend that you not use your chimney at all. Just vent it out the side of the house like I'll show you, and it'll really work well. That's just another pump for the kitchen radiant. It pulls it off separately. Okay, so we've got that. We got that. I'll show you a view around. Okay. And if anyone has any ideas about why the heat comes up naturally to the attic, that would be helpful. Okay, so here's where we are. We have 3 relay boxes to handle all these zones. And a relay is just basically a switch. That's all it is. You really shouldn't be afraid of it. Basically, on the bottom is 120 volt wires. Let's say each one here. It's a positive and a neutral. And what it does is, in other words, instead of running 120 volts up, let's say, to your attic, to a thermostat to turn on the pump, what a relay does is, you have over here, up here, you can run it on 24 volts. So it just sends up 24 volts from here, these wires, 24 volts up to the thermostat in the attic. You can just run these thin wires. And then when the thermostat needs heat, it just connects those two. It just connects a set. Here. It'll just connect these 2 wires, and that'll tell the relay box to, let me just get some light because I don't think you have a good enough light here. Let me see if I can improve that. Okay. Basically, the thermostat just connects these 2 wires, and that'll hits the relay over here, one of these relays, which will then connect the bottom 120 volts and send it to the pump over there and turn on that pump. That's all a relay box is. That's all relays are. They're just simple switches. Instead of having a person there saying, it's cold up, let's turn on the switch, the relay box does that automatically. Just a switch, sending the 120 volts to the pump. Now, let me just show you a thermostat. Huh? Now, sorry, let me go show you a thermostat. Here's a thermostat. Take this off. And what you can see is there's just 2 wires there. And if you connect those 2 wires and just jump them, that are the 2 wires leading into the relay box, and that would turn on the 120 volts to the pump. And looking at this is the Honeywell Thermostat, which I really highly recommend. I'll try to give you a shot at that. Let's see. See if I can get some better light on this. Here's the Honeywell Thermostat. It's a nice touchscreen thermostat. You touch it, you can program it. I think it cost about $80. I'd buy it on Amazon. And you program it, and it gives you 7 days. You can program each day differently, and you can program it 4 settings per day. So you can really program the heck out of this thing. And it really will save you a lot of money on heating by shutting off the heat when you don't need it. So I very much recommend you get this 7-day Honeywell thermostat. It's really been excellent. It's easy to program. It's a touch screen. You can schedule it. You schedule the days. Let me see if I can get a better view of it. It's just difficult with the lighting. Here. You program which days to use it, and wake, leave, return, and sleep. It's really excellent. The other thing to know is when you mount these thermostats, I really just discovered this. It depends what you're mounting it on. If you're going to mount it on sheetrock, let's say you're just putting it on wood, like here. If you were to put it here on sheetrock or wood or sheetrock, that's fine, because the system, because it's those are good materials to mount it on. But I discovered, this house is 100 years old, and I've discovered, especially with the air conditioning, when you put it, we mounted one or two of them onto plaster. We have like the plaster about an inch thick in this house. This house was built in 1912. And when you mount it on plaster, I've noticed particularly the air conditioning, it would get warm in the area. And even though it was registering cooler, it just felt warmer. And what I discovered is that if you mount it on plaster with so much plaster, the plaster might get cooler or warmer and stay cooler even though the area gets warmer. So in other words, if you have air conditioning and you know, the plaster will get cool, and even though the air might get warmer, the plaster stays cool. And if you have your thermostat mounted to that plaster, the thermostat's going to register cooler than the room actually is. So what I did is if you're mounting it on plaster, put a piece of insulation of some sort, some little very flat, thin insulation or packing foam of some sort between the plaster and the thermostat, so that the thermostat isn't instead of measuring the air, measuring the temperature of the plaster behind it, which really will throw off the thermostat by a couple of degrees. So I actually found I was able to cure the problem by putting a thin piece of insulation of fiberglass behind there, and then all of the thermostat worked a lot better after that. But okay, let's turn on the system. I'll put the thermostat back. Just snaps on. And the problem, actually, let me just show you one other thing. The only thing I don't like about these thermostats is they have 3 batteries on them. And when you have a house with 10 thermostats and each one has 3 batteries and you have to replace them once a year, you need a power source on these because you're just connecting those 2 wires basically. So you have, and those don't provide power to the unit. That's just a circuit on the relay box, those 2 wires. So you need 3 batteries. You have to replace them once a year. It's a little bit of a pain, but all right. So now we'll turn on the hot water to show you how the boiler operates. This is the vacation switch it's on. This is the intelligent timer system. Zone 4 is the hot water. We'll turn it on. You can manually turn it on. Now let me show you what happens. The hot water starts flickering. It's got power. The system says safe startup, it said safe startup, drive purge, which means I think it's clearing out the air from inside that's already in there. It's going to start filling it with pre-purge. It's going to start filling it with gas. So what you know from that blinking light on the hot water tank is that the hot water tank is on, and it's indicating that it's not getting, I don't know exactly what that means, but it's starting. But the hot water is not at the temperature it should be, which I think is about 120 degrees. You can set it within the hot water tank. So basically now that the boiler's now getting the signal that a zone, which is it knows to be the hot water, is set. And the thing to know also is that you want to set the priority for the hot water from within here. Don't set it on the relay boxes, which you can. There's an option there. The system works a lot better when the boiler is controlling the priority itself. And you do that by running the hot water tank through directly into the boiler. So don't let your contractor say, oh, you can run it through the relay box over there. No, there's much better control of the hot water tank when it's run through here, because the boiler can then, as a safety, also say, wait a minute, the hot water tank hasn't been satisfied in an hour, so I'm going to then forget about the hot water and give heat to the house because there's a problem. It can't do that if you run that through the the hot water tank through the relay boxes. Okay, now it's running, and you see the boiler inching up 85 degrees, 86 degrees. It's getting hot. Now let's check it out. Here's the little light on the pump, which means the pump is operating. It's not always easy to tell it's on, but with that thing, with the light, you can tell. All right, so let's go. Let me just show you one other thing. The only negative I have about this boiler is this. Look at that computer system. Who the heck's going to fix that thing? Burnham SG2.1. Who the heck would fix that? I have absolutely no idea. You need a computer operator here, which means if there's a problem, they'll just replace it. It would be an expensive replacement. This red wire over here, don't touch it. I've gotten shocked from it. Okay, let's go take a look outside and we'll tell you, we'll see how it's operating. Go outside. Okay, here we are. There are two pipes. This pipe sucks in the air which is going to be burned in the boiler. There's a little metal mesh to prevent things from falling in there. Now this is the exhaust. It's actually too close to the house, the exhaust pipe, and sometimes in the winter you get condensate touching the wall and building up on the wall. So what I've done is I put this plastic thing on, which in the winter gets very cold, and when the condensate hits it, it just turns into water and it drips down without touching the house. Now you can see this is the exhaust from the boiler. I can put my hand here. It feels about 90 degrees, I would say, over here, and it's very wet. You can see, I don't know if you can see, my hands have condensate on them, a little bit, and it shows you how efficient this is, that you don't need a chimney, that you can just exhaust it out of this plastic PVC. So I highly recommend this boiler, though I am concerned at how technical it is, that you need a computer inside there. I'm more comfortable with simple systems, but I have to say the efficiency of the boiler is such that I really would, you're saving so much money per month that it really will pay for itself, even with the repairs. So I recommend it. Call your local natural gas provider, see if switching can save you money, if there are deals involved, and good luck to you. You'll save a lot of money if you install this type of a system.